Hi, my name is Aaron Sampson. Computers are a wonderful tool that require hardware to operate, but need software in addition to operating systems to truly get the most out of them. At one time, software was a rather rare commodity, but today we're faced with a wealth of choices for performing business or personal tasks. In this course, I'll explore the basics of computer software concepts, beginning with various kinds of software and application delivery methods. Then I'll introduce architectural models, software licensing, and software installation best practices. Finally, I'll cover the ins and outs of web browsers, including browser configuration. Upon completion, you'll have built a foundation for the basics of IT. This course helps to prepare learners for the CompTIA IT Fundamentals or ITF Plus certification exam FC0 U61. In this presentation, we'll provide an overview of the various types of productivity software applications and suites that are available, along with their basic use and characteristics. Now, the name draws from the fact that these types of applications are designed to facilitate productivity, mostly in a workplace environment, but for home use as well, and they can be used to create a wide variety of document types to suit the needs of just about any situation. Now, there are many types of productivity software applications available these days, and in fact, depending on your job or your needs, when it comes right down to it, just about any software could be regarded as productivity software, provided it allows you to create whatever it is you need. But common examples include word processors, spreadsheets, presentations, such as the one you're watching right now, databases, web browsers, and diagramming or graphics software. Now, in the earlier days of my career, it was quite common to simply purchase a single application, such as a word processor or a spreadsheet, not only because there were fewer choices available back then, but also due to the cost. So we often had to make the choice as to which applications we felt would be most important to us. But by around the early 2000s, it started to become much more common for software providers to bundle their applications into what is now commonly referred to as the software suite, meaning that most of the applications all came together on a single media set, and you could then choose to install any or all of them at your discretion. While the entire suite was still more expensive than any single application, it was typically less common than buying each one separately. Plus, some suites started to include additional features or applications that weren't available on their own to enhance the overall package. Among the more commonly used examples are Microsoft Office, which bundles together Word, Excel, PowerPoint, Outlook, and others, Google Workspace, Apache OpenOffice, and Apple iWork. While there are certainly differences among each one, they each tend to include at least a word processor, a spreadsheet application, and a presentation application. The advantages provided by current productivity applications include improved accuracy with auto-correcting features to reduce both spelling and grammatical errors, increased efficiency through automation features such as macros and templates, greater flexibility due to the number of ways by which data can be manipulated, and the fact that most applications within a suite are very compatible with each other and able to share data. For example, a table from a spreadsheet can be pasted into a document if you're creating a report, but the table can be linked so that if the original spreadsheet version changes, that change is reflected in your report. And they provide increased collaboration by supporting sharing and multi-user files, whereby members of a team or a department can all work on the same file, and changes are tracked so that everyone knows who made which changes. So when it comes to choosing any given productivity suite or application, clearly there are many choices, so considerations should include compatibility with multiple platforms if, for example, your organization supports several different operating systems or several different types of devices, as well as with other applications, particularly if you interact with external entities often. Reliability, not only in terms of whether it will run in a stable manner on your device, but also that it doesn't compromise the security of your environment. and its accessibility, which in this context refers to whether the application is available through other means, such as having online version that can be accessed by using cloud services and a browser, as opposed to only having it locally installed on each device. For example, if you have a desktop computer at work with Microsoft Office installed, then clearly you can use it on that computer, but if you also have a laptop that you use while traveling, then Microsoft Office would also have to be installed on that system as well. But with a cloud-based service such as Microsoft Office 365, then you can access those applications on any device from anywhere as long as you have internet access, so separate local installations are no longer required. Of course, you also need to consider the tasks you need to perform, the features you require versus those that are included in the suite, how easy it is to learn and use, and of course your budget. Ultimately, there are many options available these days, far more than were available back when I began my career, so be sure to consider these and other factors to be sure that you find the most appropriate productivity suite for your needs. In this video, we'll examine the role and types of collaboration software, which are applications that are designed to allow many people to work together on the same project while increasing the ability to communicate and share information across those projects, and to allow many users to participate, regardless of where they might actually work or reside. Typical examples of collaborative software applications include email clients, project management, video conferencing, document sharing, instant messaging, and online workspaces. Now, just quickly, in our previous video, we discussed productivity applications, and many of these examples might sound as though they should be classified as productivity applications as well, particularly something like an email client. And it's certainly not wrong to say that email helps us to be more productive, but some of the primary characteristics of collaboration applications include the ability to enhance communication among users and to organize people and resources. So it's simply more appropriate to regard an email client as a collaboration application as opposed to a productivity one. But there can be a lot of overlap among these categories. By using collaboration software, members of a team can brainstorm ideas, with each member contributing to the overall result. Regular group meetings can be held to ensure progress is on track, and any information obtained by any member can be instantly shared with any other member, and if integrated with cloud services or even implemented on a WAN, team members can be anywhere in the world and can have instant access to any aspect of a project at any time as long as connectivity is available. Advantages of their use include better productivity, which of course comes back to my point about there being a lot of overlap in terms of categorization. But in this case, greater productivity is almost a byproduct of enhanced communication and more effective teamwork throughout your organization. Plus, those who manage teams can do so much more effectively due to the inherent project management capabilities built right into most collaboration applications. Like productivity suites, there are several options available, each with varying features and services, but these days some common features of collaboration suites include an instant messaging and/or chat utility, a task management component, document sharing, mobile platform support, and compatibility across several different platforms. For example, the ability to run the suite on both iOS and Android devices. So, when considering which collaboration application or suite to implement, factors should include the specific needs of your team or organization, your budget, of course, the features and services included, its ability to integrate into your current environment with respect to the devices, operating systems, and other applications in use, its compatibility across multiple platforms, what kind of support is available from the vendor, and what kind of security it offers through features such as multi-factor authentication and data encryption. Again, like productivity suites, there are several options available, so be sure to consider these and other factors carefully to ensure that your choice of collaboration software provides the benefits they're designed to offer. In this presentation, we'll describe the role and types of business software, which is certainly a fairly generic term, at least with respect to what constitutes a business, because of course, clearly a business can provide just about any type of service, but almost any business can benefit from specific types of software that are designed to help ensure that the business can stay on track. Now, the specific applications implemented by any given business will of course depend on their specific needs, the size of the organization, and the tasks they need to perform to provide the services they offer. Toward that end, common examples of business software types include database applications, project management, inventory and asset management, and perhaps most commonly, some kind of accounting software. Now, just a quick note about database applications. There can be many varieties and types of databases, but at their core, databases all have one thing in common. They all store collections of records. So, what's a record? Well, as a very common example, if you've ever purchased anything online, then you very likely filled out some kind of a form that details your personal information, such as name, mailing address, email address, phone number, and payment information. Well, to the supplier or vendor, that's a customer record. Your information is then likely assigned some kind of unique identifying value to ensure that it's distinguishable from all others. Then all records are gathered together to create the database. Now, that's only one example, but every database stores records, usually in the form of tables that can then be related to each other because as customers, in this example anyway, we're making purchases. But of course, I might make many purchases, as might every other customer. So each purchase is a separate record as well, stored in a separate table. But every purchase needs to be traced back to the customer who made it. So while purchases are stored separately from the customer, the records can be related to each other by including a value in the purchases table for the customer who generated that purchase. Because of that connection between the customer and the purchases tables, that's what's known as a relational database. Now, not all databases are relational, which comes back to my initial point about there being many types of databases, but again, all of them store collections of records in one form or another. As for obtaining business software, there are two primary options. Many applications can be bought off the shelf, so to speak, or they can be custom designed either by your own internal developers or through contracted services. Now, your choice will be dependent on your needs, of course, but business applications, particularly databases, are often very specific to the nature of your business itself. Off-the-shelf applications tend to be fairly broad and or standardized in their feature set, which makes them a good choice for many organizations, but they might not be specific enough for your needs. Now, clearly anything that is custom designed can be as specific as you need it to be, but it can take quite some time for it to be developed in the first place, and that can be quite costly. Whereas off-the-shelf products are ready to be implemented immediately, and they typically cost less. So again, the choice will depend on your needs. Now, looking a little more closely at each type, as mentioned, database applications are used to store and retrieve data in the form of records, which themselves can be queried, updated, or deleted, and they can be in a structured format, meaning that records are stored in tables with specific formatting rules, or they can be unstructured. Now, some common terms you might hear for each type include SQL, often pronounced SQL, which stands for Structured Query Language, and NoSQL, which basically means that there is very little in terms of that structured format. A structured database would be the example I mentioned earlier, whereby the online retailer needs to store all of our customer information using specific columns such as name, mailing address, email address, and payment information, then relate that to the purchases we make. Each purchase would similarly outline specific details such as the date of purchase and the products we ordered. A simple example of unstructured data is a standard document. You just start typing with no specific details or formatting rules. But in terms of database applications, storing something like social media posts to determine what topics are trending right now would be a common example. The content of the posts themselves might include any information, so they don't have any structure, but the overall theme might be consistent, such as a current news story or a new product or service that has just been released. But the only value stored is the post itself. No other related information is required. Project management software should typically include features for planning and scheduling, managing collaboration and teams, resource management, budget management, documentation, and reporting. Now, while most project management applications would include these features, another consideration is whether your application is capable of integrating with other business applications, such as the financial application, which could be especially helpful for budgeting. Similarly, if it can integrate with your human resources application, then personnel assignments would be easier to deal with. For example, if an employee that is part of your team is transferred to another location, that could immediately be reflected in your project management application. Inventory and asset management applications can be used to store asset or product information such as warranties or quality control. It can track where any given item is currently located within your organization. For example, if your company provides mobile phones to your employees, it would track which device has been assigned to which user, detail the quantity currently in stock and indicate reordering levels, and manage shipping schedules. Lastly, and possibly most importantly, accounting software is used for standard bookkeeping tasks such as entering invoices, managing expenses and payments, and reconciling your banking activities. Businesses of virtually any size can benefit from accounting software, but like all other applications, the features you need will depend on the nature of your business. But considerations should include its ability to also manage your customer relationships, generate reports such as year-end summaries or assets versus liabilities, its ability to integrate with other applications such as inventory or HR applications, the security it offers, and whether it can be accessed from the cloud. So, while there are many varieties of business software, they're all designed with the goal of supporting your business operations in mind. So, regardless of the type or size of your business, be sure to investigate business software options to give your business the best chance to grow and thrive. In this video, we'll examine the methods by which applications can be delivered to systems throughout an organization, which is also commonly known as the method of deployment, but it simply refers to the manner by which any given application arrives on any given device. So there are three primary methods available, including local installations, hosted on the local area network, and cloud-based, which means it's accessed via the internet. Now, the method you choose will typically depend on the quality and/or performance you need from the application, and the continuity of service, which refers to the ability to access the application under any circumstances, as well as how consistent the user experience is. For example, some applications can be accessed from a locally installed instance as well as through a cloud service, but the functionality might not be the same in both cases. Now, each of these factors will become a little clearer as we take a closer look at each option, and there isn't always a single definitive solution. So, in many cases, it's a matter of just getting the best results you can. So, beginning with the local installation, this means that each instance of the application is installed locally on each device in use, which also means that no network connectivity is required because the application in its entirety is stored on the device itself. And it also means that any data generated by that application can be locally stored as well, although you would likely still have the option to store data on a network or even in the cloud. But the point is that nothing else is required to use the application nor store the data. Everything can be done on the local device itself. Local installations tend to perform quite well provided the device you're using has adequate resources, and because they don't require any kind of connectivity, the application can be used in any situation. But the primary disadvantage is that you must have that device with you. For example, if the application is only installed on your desktop computer at work, then you can't use it while you're at home. Now, a laptop is certainly a more portable option, but if you're traveling and you leave your laptop at home, then you're still without the application. An application that is hosted on the local area network means that there is a dedicated server that runs the application itself, and individual devices just use some kind of interface, which these days is commonly a browser, to access the server-based installation. In this situation, a connection to the network is required, although no connection to the internet would be required. As long as your device is on the same network as the server hosting the application, then you'll be able to access it. The benefit of a network-based application is that very little, if anything, needs to be installed on local devices. Again, in the case of a browser, virtually every device has one already by default. Even if it is a more customized interface that does have to be installed, they're typically very lightweight and only require minimal resources. Network-based applications can also provide very high performance because they run on servers that are typically very powerful, but because all users are connecting over the network, the amount of traffic on that network needs to be considered as well. They can also help to extend the lifespan of older client devices because all that's needed is something like a browser, so newer versions and/or upgrades typically don't have to consider what type of client devices are being used. And on the topic of upgrades, when an upgrade to the application itself is required, you need only upgrade the single instance on the server, as opposed to upgrading every instance if it was locally installed on each device. Now, just quickly, for those who might be familiar, I do also want to mention the option of deploying applications from a network. This might seem like a bit of a hybrid option, so to speak, between a local installation and a network-hosted application, in that a network is initially required to receive the application, but ultimately, the application gets installed locally on each device. Network deployments are simply an option to make local installations faster and easier. It's simple enough to install any given application on any given device, but if you have hundreds or even thousands of devices that all need the same application, then manually installing it on each one would take an exceedingly long time. So the network is used to simply distribute the application to client devices in an automated way. So again, although the network is required to receive the application initially, once it is received, then it's no different than any other local installation. Lastly, cloud-based applications are in fact very similar to network-based. It's just that the servers hosting the application are on the internet instead of your local area network. This approach is also known as software as a service, meaning that you only pay for the use of the application, not the application itself or any of the infrastructure required to host it. All of that is managed and maintained by the cloud service provider, and we as customers simply pay to be able to use the application, just like we would pay for any other service. Now, cloud-based applications absolutely require full internet connectivity, and we also have to subscribe or create a membership account with that provider. Depending on the application, you may still be able to store data locally, but in most cases, the data also resides in the cloud, so we don't have to concern ourselves with managing local data either. Software as a service applications have many benefits, including the ability to make use of very robust services that we might not otherwise have access to, simply because it would be too expensive to implement all the required infrastructure on our own. 24/7 365 access as long as you have internet access, and like network-based applications, no client software to implement or manage because in almost all cases, the only client required is a browser. However, software as a service applications can still be costly depending on what the application is, and how many users are accessing it, because in many cases you pay either per user or just at an overall usage rate. So the more people using it, the more it will cost. And while internet connectivity is certainly convenient in most cases, if you have no internet, then you have no access. So, as mentioned, there is no single solution that is always the best option for every situation. So, in some cases, you might see a combination of options. But ultimately, the best choice for your organization will once again come down to your specific needs. In this video, we'll provide an overview of application architectural models, which refers to the fact that many applications are built using a layered structure, including a presentation layer, a logic layer, and a data layer. Now, we'll take a closer look at each of those in just a moment, but these layers are implemented as tiers, which leads to many applications being referred to as having a 1, 2, 3, or multi-tiered architecture. And what's interesting about this approach is that the tiers do not all have to run on the same computer. Now, to help visualize that, you might first need to rethink what the term application means. In that we tend to think of an application as a piece of software that you simply install on a computing device and you simply launch it when you need it. While that definition does cover a lot of applications, that's not the only definition. Perhaps the most common example of a multi-tiered application is using a web app. And in those cases, we might also just tend to think that we're just using websites. But in many cases, we're using them to accomplish a task, which in essence means that we're using an application. Among the most commonly used web apps is something like online banking. Again, we might just use a browser to get to the website of our bank, but we typically don't just browse and/or read information about the bank and its services on that site. We log in, we access our account information, we transfer funds and pay our bills. So by providing us that level of functionality, it is an application, not just a site. But everything that actually takes place at the bank, such as transferring funds from one account to another, clearly does not happen on our local computers. So we're simply using an interface to perform a task that occurs on a server at the bank. So the tiers of that overall application are running on separate computers. So as mentioned, when it comes to a multi-layered application, there can be a number of tiers with respect to its architecture. So they're often referred to by that number. Common approaches include a 1-tier architecture, 2 tiers, 3 tiers, and N tier, where the N can stand for any number greater than 3. Now, as you might imagine, a 1-tier application is the simplest architecture, and it involves placing all required components of an application onto a single platform. Or to put that another way, all layers are implemented on the same device. So coming back to my point about how we tend to think of applications as just something we install locally on our computers, well, 1-tier applications are exactly that. Every 1-tier application is entirely self-contained, and it can run on a single device with no other components or systems required. In short, if you can disconnect your system entirely from all networking so that it is entirely isolated, then launch and run your application without issue, then it's a 1-tier application. And generally, most of the applications that you might see in something like the Start menu of a Windows computer would be 1-tier applications. A 2-tiered application, however, involves only running an interface on the client with data stored on the server. So coming back to the layers mentioned on the first slide, the interface we use is the presentation layer, because this is literally what we see as users. We are presented with an interface. The data on the server, of course, is the data layer, and the logic layer, which refers to the programming and the processing of that data, will typically reside on the server as well, although it's worth mentioning that it doesn't have to. There are some cases where the logic layer might reside on the client, depending on what the application is. But regardless of where it resides, there are still only 2 systems involved. So there are only 2 tiers. One system just happens to host two layers in the same place. A common example of a two-tiered application is something like a custom database that has been designed for your organization. End users have the interfaces locally installed on their client systems, but no data resides on those clients. All of it resides in a centralized database on the server. Hence, a three-tiered application uses three separate systems, with the presentation layer still running on the client, the data layer still running on the server, but a third system hosts the logic layer. So each layer is now hosted on a dedicated system. Now, it might seem at first glance that this is only complicating the overall architecture, but in fact, this results in applications that are much more robust and reliable, because for the back-end logic and data layers that run on servers, those servers can be implemented as clusters of servers, whereby the overall workload can be balanced across each node of the cluster. And if any one server should fail, the remaining servers can pick up the slack, so to speak, which makes these applications much more scalable as well. As the workload increases, you can simply add more servers to the clusters. Conversely, if the workload decreases, servers can be removed from the clusters. Lastly, N-tier, as mentioned, has more than three layers. There is still a presentation layer on the client, a logic layer, usually on a server, but an additional layer is included known as the data access layer, which can be used to control and manage access to the database or data layer. For example, the database layer might be implemented on a server that hosts several databases for different applications. And while it certainly can control and manage access to its databases on its own, the data access layers might be used to ensure that all applications and requests that are bound for that server are authenticated through the data access system before they even reach the database server itself. This offloads the process of handling authentication requests to the data access server, thereby alleviating that workload from the database server, which can help to increase performance and also provide greater scalability. So to finish up, the reason why these layers are implemented across different tiers is in fact primarily for performance, reliability, and scalability, which is absolutely required by the applications of today. Coming back to my earlier example of online banking, there can be millions of people using that overall application with many millions of transactions happening each day. So by separating out each layer onto its own dedicated tier, as the demand grows, so can the resources available to ensure that the application as a whole continues to run in the manner we've come to expect. In this presentation, we'll provide an overview of single platform software, which, as its name indicates, is an application that is designed to work on a specific operating system platform, such as Microsoft Windows or Mac OS, but not both. In other words, that application is typically unavailable for platforms other than the one for which it was designed. These types of applications are also sometimes referred to as native applications. Now, there can be a number of reasons as to why developers will create apps for specific operating systems, but any decision is based on the fact that each operating system has its own features and benefits, and the number of potential users of that operating system is often a key consideration with respect to the cost of development versus the potential profit that could be generated. In short, if I'm a developer and I think that I'd like to create an application that will in fact run on more than one platform, then its development will be considerably more complex and therefore more time-consuming and more expensive. But that might also result in a much higher profit margin because you're covering a much larger section of the marketplace. Conversely, if an app is developed for only a single platform, then it can be constructed much more quickly and it will cost less, but it won't garner as much of the market. So the balance between those two factors needs to be worked out as best as possible when faced with that decision. There are other key considerations for single-platform apps, including the fact that they tend to perform very well because they don't have to be coded for multiple operating systems. So there's a lower chance of processing errors or lags in accessing certain features of the OS. They're typically implemented as single-tier applications as well, meaning that everything is self-contained within the application itself, so it doesn't rely on any external components. It will run offline, so to speak. And developers can focus on more specific languages, leading to greater familiarity with those languages and faster, easier implementation. In essence, they become more of a specialist as opposed to a jack of all trades. Single platform apps also tend to have much more consistent user interfaces and/or user experiences. For example, on a Windows system, many applications have a very similar look and feel, which translates into easier and faster user adoption. And updates and patches are likewise only created using the same code as the original application, which typically also means that they're easier to identify because it's likely that any given issue being experienced is consistent across all instances. Whereas if it was a multi-platform app, problems might be very inconsistent across each platform. As such, single-platform apps have several advantages, including high performance, and they can be released to market much more rapidly, which of course is certainly very attractive to both users and developers. Users have a much better experience due to the high performance, and developers can start profiting from their efforts sooner and move on to the next project more quickly. Not only are they easy to create from the developer's perspective, they're also easy to deploy and manage by administrators and networking professionals. Almost any single platform app can be distributed through various automated methods or even directly from the platform's inherent app store. Their specialized nature also makes them more stable and reliable, and they'll generally run on several different versions of the same operating system, such as Windows 10 or Windows 11, thereby increasing their usability. So, if you're considering a career in software development, there are certainly advantages to single platform development, but like most things, any ultimate decision will almost certainly depend on your specific circumstances. In this video, we'll outline the advantages and disadvantages of cross-platform software, which, as its name indicates, is software that is available for multiple operating systems and platforms. Now, while such applications can be run on different platforms, there are still two basic types with respect to how the software must be developed. The first type requires that the application be compiled for each specific platform on which it will be run. It's still the same application, but compiling refers to the process of packaging the base code into an executable format. So you would end up with Application X for Windows and Application X for Mac as an example. The second type does not require any kind of specialization to run on any given platform, so it would just be Application X, and it would inherently run on all platforms for which it was designed. As for some of the key advantages of multi-platform apps, while the overall cost of development might be higher than a single platform app, the cost effectiveness can be higher because, quite simply, once the app is completed, it's available to a wider audience. Since the application was designed from the start to support multiple platforms, then clearly compatibility is an immediate advantage because it does run on multiple platforms, and as such, developers don't need to worry about synchronizing separate sets of updates across the versions for each platform. Any given update applies to all platforms. Now, while increased compatibility is an advantage, it can also introduce some concerns. For example, if your organization supports users who run both iOS and Android mobile devices, the inherent differences in the feature sets of each platform may cause some issues with opening or viewing files correctly. And believe it or not, something as seemingly innocuous as different font support can cause significant issues with viewing a file. Because if the font that was used to create a file on the original device is not available on a device of a different platform, the content may become very difficult to read due to a font substitution. Similarly, differences in the way by which each platform handles images can cause problems with viewing a photo across each platform, and the same might apply to any kind of media playback application. So, while the application itself might install and run without any issues, accessing the same type of content within those apps can sometimes be problematic when using multi-platform applications. Once again, like most things, the choice of single platform versus multi-platform will simply come down to your specific needs or circumstances, and there is no single solution that fits with all situations, so be sure to consider each approach from as many perspectives as possible to determine the best solution for you. In this video, we'll examine various considerations with respect to software licensing, which in essence allows us as users and consumers to install and use the software that is developed by any given vendor, while ensuring that the vendors are appropriately compensated for their work. Now, that said, licensing overall defines much more than just our ability to use any given application. You may have noticed that in many cases, when you install a software application, there is a page presented to you during the installation, often referred to as the End User License Agreement, which details and defines the usage and permission rights of the application, the number of users that are allowed to install the same instance without having to purchase additional licenses. It confirms that the application has a copyright and describes any limitations. In addition, it will often cover warranty information, including vendor support responsibilities and updates, and usually completes with the legal ramifications if the terms presented are violated. Now, I would guess that it's safe to say that most of us have likely never read an end-user license agreement in full. We often simply scroll to the bottom of the page and click on Agree or I accept, but in doing so, we acknowledge all terms outlined. So if an issue were to arise, we basically can't blame the vendor because we agreed to those terms. But when it comes to software licensing, there are several models in use and several different approaches, the choice of which usually comes down to how you access the software and who developed it to begin with. One primary consideration is the one-time purchase versus subscription-based, whereby you pay monthly or possibly annually to use the application. One-time purchase licensing has the benefit of no expiration. Once you pay for it, you can use it for as long as it will run on your device. But they also tend to have limited transferability. In other words, if you want to install the same application onto another device, you might not be able to. Now, that said, many one-time purchase applications do realize that people often own more than one device, and or that the application might have to be reinstalled from time to time if, for example, you had to reinstall your operating system. So most won't cause any issues if you attempt to install them perhaps 3 to 5 times, but you certainly could not use that same instance to install it on every computer in an office environment. Subscription-based tends to be less concerned with the number of devices, but it might still only allow a limited number of user identities. For example, many subscription-based applications run in the cloud and only require a browser, so you can likely access that application from any device, but you would have to log in with the same user ID. So there might still be limitations on how many user IDs can be used. Now, in both cases, you likely can purchase more licenses if needed, but of course with a cost per instance fee being applied. Something else to consider with these models is updates. Once you install the one-time purchase software, while it may certainly receive updates to address bugs and introduce some new features, its core version remains the same for its entire lifespan, and ultimately the vendor will announce that they are halting support for that version. Now, that doesn't mean you still can't use it, but at that point, it will no longer receive any updates. In addition, the vendor is no longer obligated to provide any support should you contact them with an issue. Subscription-based software, however, always provides you with the latest version, and as long as you continue to pay for your subscription, you'll have full support available at whatever level is appropriate to your subscription. In short, you'll always be using the latest version. And if it is a browser-based version hosted in the cloud, you'll never have to update anything locally other than possibly the browser itself. Another licensing consideration is proprietary software versus open source. Proprietary is exactly as its name indicates, in that the application is fully owned and copyrighted by a commercial organization such as Microsoft or Apple. As such, the application itself remains the property of that organization, and we simply pay to use it. Open source, however, is not owned by any organization. Anyone can access, inspect, and even alter the code. In short, meaning that the software is created by a community of developers. So, open source software is typically available to anyone at no cost, which might immediately beg the question, why doesn't everyone just use open source products then? Well, in short, some people do. But the reason why you don't see it everywhere is precisely because it doesn't cost anything. Therefore, open source software on its own does not generate any revenue. So, developers typically aren't keen to dedicate all of their time and energy into developing something that isn't going to be profitable. So, open source software tends to start out by someone who needs to create something for a specific task. Then perhaps someone else needs something similar for a task of their own, but with a few extra features or a few minor differences. So they'll start with the same base code, then introduce their own additional functionality. Then the product simply grows from there. It might ultimately become the foundation of something that can be profitable, but the core code itself won't ever be. Now, that all said, it is worth mentioning that the more modern approach to open source applications is that while the application itself might be free, if its exposure is high enough, the application will also run ads so that other companies will pay for ad space within the application. You might have noticed this with many of the applications on your smartphone or tablet, especially with games. The app is free, but periodically you have to watch an ad while you're running it. And in some cases, you might be able to remove the ads, but you would then have to pay for the app. In either case, that product is now generating revenue one way or another. Now, when it comes to activating your license, with subscription-based applications, it's usually just a matter of providing a payment method, most commonly a credit card. And that's all there is to it, other than you creating your own user ID. But for one-time purchase applications, you typically have to activate your license by entering something like a serial number or perhaps a product key during the installation or shortly afterward. In other words, some installations will allow you to skip over the page where you enter the product key, but then if you don't activate that license within something like, let's say, 30 days, it will stop functioning. Now, if you purchase the application on physical media, such as a DVD, then the serial number or the product key will almost certainly be included in the packaging. And if it was something that you downloaded, then the most common way to receive it is by providing an email address to which the key will be sent. Now, the serial number or product key that you enter during the installation not only proves that you have a valid license, it also indicates what kind or level of license you purchased. For example, if you only purchased a single-use license, then by entering that key, it means that only you can use it. Now again, recall that most vendors do realize that many people have more than one device, so it may still allow for a few different installations, but it would only be a small number, such as maybe 3 or 5. But more to the point, you could not install it, let's say, 100 times on every system in an office environment. But of course, there are situations where exactly that is required. In other words, for office environments, administrators and technical support personnel don't want to have to manually install an application hundreds or even thousands of times on each computer and have to enter a different product key each time. So in those instances, there are licenses available that can be based on a group of users, the physical site you're in, or based not so much on the total number of users in any given environment, rather how many might be using it at the same time. For instance, in a shift work environment, you might have 75 people, but there could be 3 shifts of 8 hours each, with only 25 people on each shift. So you would only need to pay for 25 licenses instead of 75. These types of group licenses are also more generically referred to as volume licenses, and there can be other approaches as well, but any kind of volume license is typically only available for some type of organization, and they're often negotiated through an authorized reseller or directly through the vendor. In other words, a single person in the general public typically can't acquire a volume license. And it should also be mentioned that while group licenses are clearly going to be more expensive, they are generally cheaper than buying individual licenses for each user. Lastly, some other license types might include an original equipment manufacturer or OEM license, which is typically used only for software that is distributed with a physical device. For example, if you buy a PC with Windows pre-installed, you don't have to do anything in terms of installation, nor do you have to enter a product key, although they will still provide you with a product key should you ever need support or have to reinstall. But the software is effectively bundled with that device and has to stay with that device. In other words, the same operating system and its associated product key cannot be used to install it on a different device. An educational license is a special type of volume license, but it's only granted to registered educational institutions for use by their faculty and students, and it's usually offered at a discounted rate. And a not-for-resale license is a designation that vendors give to their channel partners for testing and educational purposes, with the understanding that the channel partners themselves will not resell those products to end users for their own profit. So the choice of licensing, like many other things, will simply come down to your needs and/or your preferences, so be sure to consider all available options to ensure that you get the most appropriate license for your needs. In this presentation, we'll examine several best practices for installing computer software, which of course allows you to make use of any given application on your computing device. Now, just before getting started here, I do want to quickly clarify that in light of the prevalence of mobile devices and app stores these days, most of these points won't be all that applicable to those types of installations. In those cases, we simply go to the App Store, locate the app we want, and tap on it to install it. So for the most part, this refers to installing software on something like a desktop or a laptop computer using software that was not obtained from an app store. In those cases, most software is installed from some kind of installation media, such as a DVD, or perhaps from a network folder, or maybe it was downloaded from the internet, but in most cases, once the installation program is launched, you'll be presented with some options to read the installation instructions, read a licensing and use agreement, and/or see some more advanced installation options, which typically allow you to specify an alternate location for the software to be installed, and/or to specify which features or options to install. Now, while you don't have to choose the advanced option by any means, if you don't, the installation will proceed with default options, which are usually fine in most cases, but if you do want to customize the installation at all, then typically go with the advanced option. In fact, in many cases, even if you do choose the advanced option, most prompts that you're presented with will show you a list of available configurable options with the default option already chosen. In other words, if you just clicked on the next button on each page of the advanced options without making any changes, you would still end up with a default installation, but at least you'd see all available options. Some considerations with respect to the application itself include verifying that it is compatible with your system and that your device meets the minimum and/or recommended system requirements to run that application in a satisfactory manner. Now, these will usually be documented within the instructions, but in most cases, even if you didn't read those instructions, the installation program itself will usually perform a system check that ensures that your device is capable of running that application, and if it isn't, it will halt the installation and you'll be presented with an error message informing you of the reason why that application can't be installed. Depending on what you're about to install, It's also not a bad idea to create some kind of a checkpoint on your system. These are snapshots, so to speak, of the state of the system as it is at that point in time, so that if the installation ends up failing or causing instability issues with your system, you can simply revert it back to the checkpoint, which discards all system changes since that checkpoint was created. Operating systems such as Windows and Mac OS both support the use of some type of checkpoint, but it is worth mentioning that standard user applications typically don't require the use of checkpoints. They're more appropriate for things like operating system updates, because if a software installation itself causes any issues, you can usually just uninstall it. But again, it never hurts to create a checkpoint. Other best practices include preparing your system to receive the new application, which in most cases refers to ensuring that all the latest security and/or maintenance updates have been applied. In some cases, an application might require a specific update to be present on your system before it will install, which would likely be outlined in the instructions, or there might also be a text file on the installation source called README, which might also detail which updates are required, but it's always a good idea to ensure that your system is as up to date as possible. You should also ensure that you have access to the serial number, product key, or credentials required to complete the installation, as many applications will not allow you to proceed without entering that information. And many applications, particularly those that have been downloaded from the internet, may only be in the form of a single compressed file such as a zip file, which requires that you extract the contents to a local folder before running the installation program itself. Most operating systems these days are capable of extracting compressed files on their own, but depending on the compression format, you might need to download the appropriate compression program first. It's also a good idea to close all other running applications during the installation process, not so much because they might block the installation, but if you have any unsaved work and the installation encounters an error, you could lose that work. Plus, some installations may automatically invoke a system reboot to complete the process, in which case you could also lose any unsaved work. But in some cases, certain applications do use shared program file libraries, in which case if another application is running during the installation, it may have already opened those shared libraries, so the installation program would be unable to access and update those libraries. This is another example, however, where most installation programs will inform you if a running application needs to be shut down. But once again, it's always a good idea to do so anyway. Depending on what the application is, your firewall and/or antivirus might also need to be temporarily disabled to allow the installation, because it's possible that your security software might think that this new installation is actually something questionable, so they might prevent the installation itself. Again, in most cases, the installation program or the README file will usually inform you if either needs to be disabled. Lastly, you should also verify that your system supports the type of media required for the installation. For example, many applications are distributed in the form of an ISO file, which is a single file that contains all files of an optical disc such as a DVD. Most operating systems these days are capable of reading directly from an ISO file, but it's not out of the question that you would have to burn the contents of the ISO to a DVD first before it can be used. And even though many applications might not require it these days, it's never a bad idea to reboot your system to complete the installation. Once again, most installation programs will inform you if a reboot is necessary, although it usually isn't necessary right at that moment. In other words, you can delay the restart, continue on with something else, then restart later if you want to. But a reboot always ensures that all system services, including any new ones that may have just been installed, are restarted fresh. All told, most software installations these days are very easy to run, and they usually don't cause any problems. But the more you prepare, and the more you learn about the installation process ahead of time, the less likely you are to encounter issues or problems that might otherwise prevent a successful installation. In this video, we'll take a look at the role and features of web browsers, which have become perhaps one of the most important and commonly used applications on our computing devices, not simply for providing access to the internet, but many applications now run from within a browser, so they aren't just used for casual browsing anymore. But for as functional as they've become, they require configuration and maintenance just like any other application. And in fact, I'd say that given their increased capabilities over the last several years, they often require more maintenance than perhaps any other type of software that we use. So, on that note, a common maintenance task might be to clear what's known as the browser cache. This is an area of temporary storage on your primary device that is used to retain data about recently accessed sites and pages, which help to provide better performance while browsing, because some of the content from any given site can be retrieved from the local cache the next time you visit it, as opposed to having to download all of it all over again, particularly content such as images, which could be rather large. But while the cache helps to boost performance, it does retain information about your browsing history, so leaving it on your computer could represent a security issue if your device fell into the wrong hands, so to speak. And in addition, the cache itself can become quite full, so in some cases there might be so many cached files that it might not be any faster to locate the appropriate content in the cache than it would be to simply download all content again from scratch. Toward that end, all popular browsers these days provide you with the option to clear the cache, including Google Chrome, Mozilla Firefox, Microsoft Edge, and Internet Explorer, which at the time of this recording has been largely superseded by Edge, but it is still supported on systems running Windows 10. Now, the specific method of clearing the cache in each browser will vary slightly, but in all of them, it's an option that can be accessed somewhere in the browser settings. And when and if you do choose to clear the cache, each browser will present you with options as to what should be cleared. In other words, it's not just a matter of deleting everything. You'll typically be given the choice as to what specific types of data to clear and which to retain. For example, you might choose to save all stored passwords so that you don't have to type them all in again, but you might choose to remove all cookies or downloaded images. Another commonly configured setting is what's known as private browsing, which is often used on computers that are shared with others, or if you're just temporarily using someone else's device. Private browsing provides additional security for those situations by not storing information such as passwords, browsing history, and payment information that was provided during your session. Therefore, when you return that device to its owner, or when someone else uses it, none of your information can be viewed by that person. Now, the feature is implemented somewhat differently depending on the browser. For example, in Google Chrome, it's known as incognito. In Mozilla Firefox, you click on the three-line menu button and choose New Private Window, and in Edge, you also click on the three-line button and choose New In Private Window, but the functionality is the same in all browsers. Depending on your environment, your browser may be configured to use a proxy server, which is common in many corporate environments where additional security for internet access is required. Proxies are typically implemented on servers or dedicated network devices, but they're placed on the edge of your network, and all requests for internet access must pass through the proxy server, which in essence will terminate your own connection to the internet at that point. Then it will retrieve the site for you, then pass the site pages back to you once they've been retrieved. This way, network and security administrators can configure filters and/or blocked sites so that if the site requested by a user is on the blocked list, or if the proxy determines that the site could be malicious, it will not allow access. So as far as the browser is concerned, it simply needs to know the name or the IP address of the proxy server. Once configured, it will forward all requests to that system. Now, if you are in an environment that uses a proxy, then your network administrators will almost certainly configure the value for the proxy server through some kind of a policy so that we as users are not able to override it or bypass the proxy server. So it's usually not something that end users will have to configure, but it's worth knowing about its use, particularly for testing or troubleshooting internet access, because if the proxy server itself were to fail, then no one would have any internet access. Many browsers also support the use of add-ons, which are also commonly known as extensions, which, as their name indicates, are additional components that can enhance the functionality of the browser. For example, various types of media add-ons can be added to ensure that you're able to view the multimedia content of a page, or they might allow you to view certain types of files, such as PDFs, directly in the browser, as opposed to needing to launch a separate application. But while they can and usually do enhance browser functionality, some add-ons can be malicious because the site will disguise them as something that is required when in fact it's some kind of malware. But fortunately, any add-ons or extensions can be added or removed at any time. And in many cases, they can also just be enabled or disabled. So if you aren't certain if something is necessary, you could just disable it temporarily to see how it affects functionality. Lastly, browser compatibility can sometimes be an issue when attempting to view certain sites. Now, site developers try to make their sites as compatible as possible, but it just isn't guaranteed that every site will be compatible with every browser. So some steps you can take to try to correct compatibility issues include making sure that your browser version is as current as possible, but in some cases it might even be the opposite situation in that the site you're viewing is quite old. Hence, newer browsers may no longer support the older components of the site. In those cases, however, it certainly isn't recommended that you attempt to downgrade your browser, so to speak, but some browsers do offer a compatibility mode for older sites. And in some cases, the site might require you to disable any script blockers that you have in place because the site requires the ability to run a script. But do be mindful that scripts can be dangerous, so be sure that the site you're trying to access is reputable. Since browsers have become such an important application, many have implemented automatic features to ensure that web pages are rendered correctly, and most sites have similarly been updated to ensure that they are compatible with most modern browsers. So configuring these and other settings manually has become far less of a concern, but nothing is ever 100% in computing, so there will certainly still be instances when configuring your browser settings will be required. In this demonstration, we'll take a look at how you can clear the browser cache for any given browser. Now, that said, the process is largely similar for most browsers, but where you will find the specific option to do so will depend on the browser itself. So I'm using Microsoft Edge in this case, but for many browsers, it is at least going to be somewhere in the settings of that browser. So what you would want to do would be to look for a settings option somewhere in the menu bar or in the button bar. And in the case of Microsoft Edge, there is a button in the upper right-hand corner that simply has 3 dots, which is known as an ellipses. If you click on this, you will find a settings option toward the very bottom of the menu, and that is what I have chosen, and this is the page that I'm on right now. So it's not immediately evident in here as to where you can find the option to clear the browser cache either. And if you aren't seeing an immediate option in your particular browser, then you might also want to look for something that refers to privacy settings. So in here, over on the left-hand side, there's a navigation bar, and we do see privacy, search, and services, because your browser history is tied to your own privacy. So generally, this is where you will find the option to clear the browser history. Now, I just need to scroll down a little bit, and we will find the option here in Microsoft Edge to clear the browsing data now. And there's also an option that says choose what to clear every time you close the browser, meaning that it will clear whichever options you enable as soon as you shut the browser down. Now, with respect to why anything is even retained in the first place, it is all designed to make your browsing experience a little easier, because it does tell you that if we were to clear the browsing history, It would include the history overall of sites that we have visited, passwords, cookies, and more. Now, it does say that only data from this particular profile will be deleted. In other words, if there are multiple users on this computer, it will not remove their data. But again, the idea is that if I visit the same site today that I did just yesterday, then anything like a password that I might have entered will be remembered so that I don't have to enter it again. Similarly, if I make some sort of an adjustment on the page to suit my preferences, that information is stored in a cookie. A very common example of that might be a weather site, so that every time I go to the site, it presents me with the forecast for my area. So that personalization is stored in cookies. So if I were to clear all of that, if I go back to those same sites, they would effectively reset to a default state, and it would be as if I was viewing them for the first time. So, of course, it's up to you with respect to what you might want to clear and or what you might want to retain. But that might also depend on the circumstances. For example, if you're using a shared device in a home environment where everybody uses the same profile, then you might certainly want to clear any information. But if everyone has their own profile, it might not be as important. Conversely, if it's your own device and you are the only user, then clearing this data might not be much of a concern. Lastly, if you are just using a very public computer, such as a system in a hotel lobby, and you did provide any type of personal information, then you might certainly want to ensure that it is cleared. So ultimately, the process is quite simple. We just have to click on the button here that says choose what to clear. And we're presented with a time range for starters, so we can hit the drop down here, and we can clear everything within the last hour, the last 24 hours, the last 7 days, or the last 4 weeks, or all time, which is quite literally right back to the first time this application was ever launched. So you simply choose the appropriate time range. Then you can enable or disable each checkbox, and notice that there are several here. And of course, this is your call. You just decide which ones you want to clear, and then click on the Clear Now button. Really, that's all there is to it. But this is a one-time clear only. So as soon as you launch the browser for the next time, it will start remembering that same information all over again. So in this case, again with Microsoft Edge, there is this option that says choose what to clear every time you close the browser. So again, you can simply enable the options that you want. Now, you don't have to enable any of them, and as you can see, they are in fact off. But it does tell you how much information is in here. So in my case, the browsing history is saying that there are over 11,000 items included, 29 items in the download history, over 1,000 cookies, and over 320 megabytes in cached images and files, hundreds of passwords, and various other information here. So again, clearing them each time would certainly result in less data being stored on this system. But if I was clearing them every single time, then I would always have to enter in passwords and or autofill information, as well as cookies and various other options. So clearly these are up to you, but if you do ever need to clear either just that one-time information or do it every time, you simply need to enable the appropriate options. Again, I reiterate that these would not be exactly the same in other browsers, but they would be very similar. So just look for that settings option, typically under privacy, or it might even be labeled browser history in terms of the settings, but basically you'll find similar options in all major browsers. In this video, we'll provide an overview of client and server-side scripting, which in itself is a process that is used to enhance the functionality of websites and or to customize the response of a server to any given client's request. To help clarify that, if a web page is simply a static page of text and images that we simply view, then there really is no functionality required. It would be no different than simply reading a document or an email. But as soon as we need to interact with that site by providing information and getting various responses back, such as when we make a purchase, then scripting is used to provide that functionality. But scripts can operate on either the server side, which is also known as the back end, or the client side, which is also known as the front end. And the location of script execution will generally depend on the functionality of the site. With server-side scripting, the scripts will execute on the server hosting the site, and the scripts are written in a language that is inherently supported by the server. And in fact, it need not concern itself with what kind of client is being used, because the client is simply making a request of the server to execute something on that server. So the scripting language does not have to be supported by the client. Server-side scripts might also be required if the requests need to access something on the local file system of the server, such as a record from a database. As for the server-side languages themselves, common examples include ASP.NET, and ASP, by the way, stands for Active Server Pages, Java, Perl, and PHP. Now, as an end user, we typically do not need to concern ourselves with these, but if you intend to pursue a career as a web developer, then you will almost certainly need to familiarize yourself with at least some of these. Now, there may be instances where server-side scripting is required, and that's perfectly fine, but there is an inherent drawback to running scripts on the server, in that if the server has to continually run scripts for virtually every client request, then not only is that server going to become very busy, very fast, particularly for a very heavily used site, but even if the server isn't all that busy, the client must wait for the server to execute the task and return the result. So there is simply an inherent delay with server-side scripts as the client waits for the task to process. And again, the busier the server becomes, the longer the wait times become. So another option is to run scripts on the client side, meaning that scripts are executed within the browser of the client computers, thereby alleviating some of the workload from the server. Now, I do want to stress the use of the phrase some of the workload because in most cases, server-side scripts are still in use, but the more scripting that can be done on the client computers, the less work the server has to do. So client-side scripting is in fact very heavily used these days, not only to improve performance, but to enhance the customizations of our experience, because you and I might both want our specific configurations of the same site. So the scripting necessary to do that is best suited to run on each of our computers as opposed to the server. That all said, it is possible that some scripts could be harmful to your computer, usually through an intentionally malicious site. But of course, we as users do not always know that a site has malicious intent. So modern browsers provide us with the option to disable client-side scripting when necessary. Now, we'll see how to do this in an upcoming demonstration, but in most browsers these days, you likely won't find an option called client-side scripting. You're more likely to find an option for JavaScript, which is the language used for almost all client-side scripts because it's just about universally supported by all browsers on all platforms. So if you need to disable it, look for an option in the browser settings for JavaScript. Now, to finish up, some considerations with respect to the use of each type of scripting include the source code of the scripts themselves. With client-side, all code is visible to the user, so if you're familiar with scripting languages, there is an option in the browser to display the code. But server-side code is, of course, not visible to the user because the output of the server code is the page itself. The location of where the code executes is, of course, the primary distinguishing factor, but again, the use of either or both will depend on what kind of functionality the site has to provide. Again, if it's just static text and images, then neither is required. If the script needs to access local resources of the server, such as a database, then server-side scripts are required. And if the site needs to be more interactive and/or customized for each user, then client-side scripts should be used. Server-side scripting is inherently more secure because the code only executes on the server and is not exposed to the client, whereas client-side scripting does not provide for any level of inherent security, hence the reason it can be disabled. Similar to the functionality required by the site overall, the level of server involvement should also be considered. With client-side scripting alone, you're basically saying that there is no level of server involvement required. So if full functionality can be provided by client-side scripting alone, then the server need do nothing more than serve up the content, which then directly translates into the overall processing load on the server. And again, the less there is, the better the performance will be, especially if it's a very busy site. And finally, choice of language should be considered, but recall that if you're only using server-side scripting, then you don't really need to consider the clients. But of course, you need to be familiar with an appropriate language as the developer. If you're only using client-side scripting, then really the only language required would be JavaScript. Again, in many cases, both scripting sides are used, but we as end users need only concern ourselves with knowing how and when to disable client-side scripting if we feel that any given site might attempt to run malicious code. And in that regard, I do want to state that most client-side scripting is harmless, and most browsers are set to allow it by default. But even if we don't know the status of a site at all, most modern browsers are quite good at detecting questionable sites, in which case we'll typically receive a prompt that warns us of potentially malicious code, and we can confirm if we want to proceed. But ultimately, client-side scripting is generally required for most sites, but it's always useful to know how to disable it for situations when you do know that the script could cause harm to your system. In this demonstration, we'll take a look at deactivating client-side scripting in a browser. Now, once again, I'm using Microsoft Edge as the browser here, so you will likely find this under different headings or different settings in other browsers, but typically it's under something along the lines of security or site permissions, and that's exactly where we'll find it in Microsoft Edge. However, the setting itself is typically not called client-side scripting. Rather, what you are most likely to find in modern browsers is an option to configure JavaScript. Now, Java refers to the scripting language, and the reason why that one is so commonly used is because it's universally supported by just about every browser on just about every platform. So this tends to be the option that you will find, again, in modern browsers. And the idea is to simply turn it on or off. So at the moment, in my case, it does say that it is allowed, and you're likely to find the exact same thing. Because in most cases, you do want client-side scripting to be enabled. The general idea is that scripting helps to improve and enhance the overall browsing experience, but scripting can run in one of two places, either on the server or on the client. Now, at first glance, it might seem like it would be preferable for scripts to run on the server because servers are a little more powerful. But you have to take into account that any given server could be very busy. It could be handling a lot of requests. So if every request of the server also required that scripting be performed on that server, then this could introduce a lag in performance, and quite simply, the script executing on the server means that something that is required to present us with that site is happening on some remote system. Therefore, there's going to be inherent latency anyway. Whereas if that script can run on our local systems, then it can perform whatever tasks it's designed for much more quickly. So generally, client-side scripting is something that you want. But it does have a potential downside in that if you end up on a malicious site, that site could invoke a script on your computer that could cause harm. So you do have the option to disable it. So again, I'm here in Microsoft Edge, and the option is found under Cookies and Site Permissions. Now, if you aren't certain where to find the option, then you will typically find an option within the settings page to search for a particular setting. And what you would be looking for in this case, again, is not client-side scripting. Really, the best option is to just type in something like Java, and you will see the option highlighted. So this brings us right to the option for JavaScript. And you certainly could type in JavaScript, but Java is all you need. So we simply need to click on the option here, and there are two choices. It's either allowed or it's not. But notice that you can be a little more selective. There are block options and allow options. So if I simply turn it off here, then this is disabling all client-side scripting. It is simply not allowed. But as it states on this page, allowed is the recommended setting to, again, enhance the performance of websites. But what we can then do is to block it for specific sites or allow it for specific sites, what's sometimes also referred to as blacklisting and whitelisting. So if we do know of a questionable site, then what we can do is click on the add button here, and we can just type in the address of that site. Now it's giving you an example of an asterisk, then a period, then the domain name. So in this case, it says star.example.com. So if I were to put in something like star.questionable.com, then this would block scripting for all sites that end with questionable.com. So I can simply add that entry, and if I encounter any other ones in the future, I can add them to the list. Now, if I'm going to take this approach, it does sort of depend on the state of the overall setting. So right now it's allowed. So if I were to specifically enter in a blocked site, then that block would override. So clearly all other sites would be allowed, but the explicitly blocked site would still be blocked. Conversely, if I turn it off, but then if I add an allowed entry, then that allowed entry overrides. So all others would be blocked except for the ones that I explicitly allow. So again, the approach is up to you, but for the most part, simply turning it on or off is the preferred option. And I do want to finish up by reiterating that allowed is the recommended option. It will help to ensure that your browsing experience is much more robust and that there isn't any latency or lag time in delivering a site to your computer. But if you are encountering questionable sites that might be causing issues with your system when you visit them, then you certainly can block that site either with the explicit block entry or by simply disabling scripting entirely. Then, of course, you can re-enable it at a later point if necessary. In this demonstration, we'll take a look at using browser extensions. Now, once again, I'm using Microsoft Edge in this particular example, but in all cases, browser extensions do exactly that. They extend the capabilities of the browser. And in fact, here in Microsoft Edge, it tells us that we can personalize the browser with extensions. And it goes on to say that they're simple tools that can customize your browser experience and offer you more control. But again, in short, they enhance the capabilities and/or what you can do from directly within the browser. Now, on this particular system, there are only two installed extensions, one for Malwarebytes, which is an anti-malware application, and one for Microsoft Outlook, which allows us to send and receive email, manage the calendar, tasks, and more without opening a new tab. So if, for example, I found an interesting site and I wanted to email the link to someone else, I could do so from directly within the browser without having to open another page. Now, in terms of accessing this feature, in Microsoft Edge, there is a button directly on the button bar that looks like a little puzzle piece. So it's up toward the top on the right-hand side, and we can just click on it, and it says Extensions. So again, it shows me the same extensions that are installed, but it also gives me the option to manage the extensions, whereby I can turn them on or off, or remove them entirely, or open the Microsoft Edge add-ons page. Now, both of those are available from within this page that I'm looking at right now. So this is, in fact, the Manage Extensions option, because I can just turn this extension off temporarily if I want to, then turn it on again when I need to. I can find out more details about this extension, or I can remove it entirely. So that's what's meant by managing the extensions. But if you want to get more, then there is a button here that you can also click that says Get Extensions for Microsoft Edge. And that would be the same option as opening the Microsoft Edge add-ons page in the button bar. And I have already opened that page right here. So when you first arrive on this page, this will just give you a breakdown of some of the more popular add-ons, and you can click the View More to scroll through, or you can just see some of the newest ones and or editor picks, or you can simply search for one if you know what you're looking for. So just as a fairly common example, if I go to the search bar here and type in Adobe and just hit enter, I will see several extensions for Adobe. Perhaps most notably, the ability to work with PDF documents directly in the browser itself. So again, this will depend on the browser you're using, but if I were to install this first extension for Adobe Acrobat, it allows me to edit, convert, and use sign tools directly from within Microsoft Edge while working with PDF files. I could also send any kind of PDF link directly to my favorite PDF viewer, like Adobe Acrobat Reader, from within the browser as well. So again, as opposed to clicking on a link and having it download the file separately, I can send it straight to whichever reader I use. So again, I'm just enhancing the functionality of the browser. So the extensions that you add are entirely up to you. And in many cases, you might get prompted to add an extension when you land on any given site. It might inform you that this site uses an extension, and it will ask if you want to install it. You can just click on yes or no, and if you decide later on that you don't like or don't want that extension anymore, you can go back to the initial extensions page and remove the extension again at any time. It's almost never harmful to remove an extension. There's really not going to be anything in there that would be necessary to support browser functionality. But after a while, you might simply find that there are a lot of extensions that you just don't use anymore, or perhaps never intended to install in the first place. Maybe someone else installed it, or it might have been something that you did install but maybe weren't particularly aware of it. You just saw a prompt on the site and you just clicked on yes to continue or something along those lines, but it did in fact install an extension. So again, they can be removed at any time, or they can just be temporarily disabled if, for example, you're just trying to determine if that extension does provide a useful service. So for example, you could just turn it off, go about your business, and then if you don't notice that anything changes, then you likely can remove that extension. Ultimately, it's really your call, but it's certainly never a bad idea to at least check on the status of the extensions just to ensure that you don't have too many extensions that aren't really providing any enhanced functionality. In this demonstration, we'll take a look at configuring browser settings and situations when you might want to configure them. And once again, this is going to depend on the browser that you use. But all major browsers do have settings that can be configured, and like any other piece of software, really the settings themselves are up to you, but it will depend on the situation. And on that note, I do want to mention that the very first page here for the settings in Microsoft Edge allows you to configure options that will synchronize if you are using the same account across multiple different devices. So in other words, you can sign into the browser basically by choosing an account that you would have on each device. And as long as it's something like a cloud-based account that is not specific to that local device, then all of the options configurable down below here can synchronize to your other devices. So perhaps most notably, things like passwords and the payment information that you might use to log into retail sites and make purchases would all be present on your other devices as long as you have already entered them onto this device. So that, of course, can save you a lot of time, and it makes your browsing experience much more consistent. Now, again, with respect to the settings themselves, they are going to vary from browser to browser. But if you are in Microsoft Edge, just getting at the settings to begin with can be done by clicking on the ellipses, which is this 3 dots button in the button bar. You can just click there, and down at the bottom of the menu, you will find settings. So that's where I am right now. And again, this profile page is what comes up by default. whereby you can configure those synchronization options under the profiles category over on the left. Now, these are all of the various categories that can be configured with respect to the settings, so clearly there are far too many to go through. So my recommendation is that you literally just go through them on your own, and when you do click on any given page, it does give you a fairly thorough description as to the options that are on that page. So right here under Privacy, Search, and Services, one of the first things it talks about is tracking prevention. And there's also a little question mark, which is a learn more link. So you can click on that and you can find out more information. But it does tell us that websites use trackers to collect information about your browsing. Websites may use this info to improve sites and show you content like personalized ads. Some trackers, however, collect and send your info to sites you haven't visited. So there are options for tracking prevention. And it shows you the three settings in this case: basic, balanced, and strict, and it gives you a breakdown as to what each setting is all about. Plus, you can turn tracking prevention off entirely if you want to. But the more strict the tracking prevention is, the less personalized your web browsing typically will be. So, like many things, it's a little bit of a trade-off. If you do want a somewhat personalized browsing experience, then you do need some level of tracking. Then if you scroll down a little bit more, there are blocked trackers that can be configured as well as exceptions. And then you can clear the browsing data and clear the browsing data for Internet Explorer as well if you're still using it. And there are other privacy options. And again, there are far too many individual settings to go through here. But there are descriptions for each setting. And again, anytime you see this question mark link, that's a learn more link where you can find out more information. Some other common settings that you might want to investigate over on the navigation bar on the left include the Start, Home, and New tabs, which basically give you options as to what happens when Edge starts. In other words, will it open the new tab page? Will it open tabs from your previous session or open specific pages? And you can configure which ones you want. You can specify what to do when you click on the Home button and or the new tab page, and configure what to do when your Windows device starts. There are cookies and site permissions that can be configured with respect to which types of permissions are allowed from the browser on certain sites. Again, you can scroll through and find out what these settings are all about by simply clicking on any given setting and finding out what the available options are. Now, if you do have multiple browsers on any given system, a common configuration option is to set the default browser. Because if someone sends you something like a link in an email and you click on the link, it will need to know which browser to use to open that link. So basically, it's just which browser you tend to use most often. And you can typically set that within the settings for any given browser. So again, that's your call. It's just whichever one you like to use the most or use most often. You can also specify what to do with downloaded files, and most notably, you can specify where they are going to be downloaded to. By default in Microsoft Edge, it's to your own user profile. There is a downloads folder in every user profile, so if you want to change it, you certainly can. And it gives you options as to what to do with each file as they download. You can also go to System and Performance, and you can specify options for Startup Boost and whether it should continue running background extensions when apps and Microsoft Edge is closed, whether you want to optimize performance with an efficiency mode, which helps to extend your battery life by saving computer resources when your device is unplugged or low on battery. And again, the idea here is that you will get a trade-off between performance and battery life, because those two are inherently incompatible. If your system is running at maximum performance, it's going to require more from your battery. Conversely, if you're trying to get the most out of your battery life, then performance won't be as high. So again, you can choose whichever option you want. And finally, to finish up, if you have gone through and you've made a lot of changes and you aren't really certain as to what they might have been originally, there is an option to reset the settings to all of their default values, which basically just sets everything back to the way it was when you first installed Windows in the first place. Then you can kind of start over again with a fresh configuration. So again, settings are entirely optional. They are designed to make the application itself more suited to your browsing habits. So ultimately, it's just a matter of exploring those options and determining whether any given setting suits your needs and/or browser requirements. For our final video of this course, we'll take a look at how you can block pop-ups and various types of scripts in your browser. Now, just a quick note about pop-ups. These were a tremendous problem back in the early 2000s when spyware and various other forms of malware were very prevalent. It's not nearly as bad as it was back then, but not all pop-ups are bad. For example, if you're on an online banking site and you just get up and leave your computer for a coffee break or something along those lines, then typically after a certain amount of activity, the session will time out for the sake of security so that someone else doesn't come along and access your banking site. But in many cases, you might receive a pop-up whereby a screen appears and says you've got 30 seconds left in your session. Do you want to continue? And that can be useful if you are just temporarily distracted by something like a phone call. So that is a pop-up, but if it was blocked, of course, you would not see that, and the site would just default to timeout. Now, that's hardly critical, but the general point is that not all pop-ups are bad. But back in those days that I was referring to earlier, they were so bad that it generally got to the point where you couldn't even use your browser. You would open up a page and so many pop-ups would appear for various ads or really anything else that you literally could not do anything. You would attempt to close one of them and two more would appear. So it could actually render your system unusable in terms of that browser at least. Now, you might have been able to install another browser that might not have been so bad, but if you only had the original browser to begin with, then of course you had to use that browser to obtain another browser. So it really could have been problematic, and this is where various forms of anti-spyware applications started to become prevalent. But because of all that, there is now an option built into the browser to block pop-ups, and again, we will also see how you can obtain some script blockers as well. So, as per all of the previous demonstrations, I am once again using Microsoft Edge. So, if you're using a different browser, you might find the option in a slightly different place, but generally it can be found somewhere under the site permissions or the security section of the browser. So, in the case of Microsoft Edge, it is under cookies and site permissions. And in fact, I should also mention that if you can't find it, then you can just go into the search settings option and just type in something like pop-up, and it might have a dash in it. But there are several results that came back in my case, but these are for specific sites. So if I scroll down, there is the option for pop-ups, and in the case of Microsoft Edge, redirects. So we can simply click on this. And once again, it's just an on-off feature. And block means to, of course, block pop-ups, which is the recommended setting. Now, what you can then do is to also explicitly block or allow certain sites. So in my case, blocking is on, which again is recommended, but under allow, there are two entries, meaning that those two specific sites will have their pop-ups allowed. And I can tell you that one of them for Azure is very similar to the online banking one, whereby it might prompt me for security-related reasons, such as leaving the session unattended for an extended amount of time. So again, you can be somewhat selective. You can block just about every pop-up, then selectively allow a few, or you could turn blocking off, which again is not recommended, but then you could explicitly block just a few sites where you find pop-ups are too obtrusive. So again, it's your call, but generally you should have pop-ups blocked. Then you can decide for yourself whether to explicitly block or allow particular sites. Now, this is also something that if blocking is enabled and you do go to a site that uses pop-ups and they are legitimate, it will likely prompt you. It will ask you if you want to allow pop-ups from that site. And if you know that site to be reputable, you can simply say yes, and that will create the allow entry for you. I did not create these entries. They were entered automatically through a prompt on the site itself. Now, another option is script blocking, and this is similar to client-side scripting, which was discussed in an earlier video, but that's not the only type of scripting that is implemented through browsers. So when it comes to blocking scripts, really one of the better options is to search for an extension or an add-on. Now, extensions were also discussed in an earlier video, but in Microsoft Edge, if you click on the button bar on the button that looks like a little puzzle piece, that's how you can obtain extensions, and I have already opened that page. And in here, if you just type in script blocker or perhaps script blocking, you'll see that there are several options with respect to blocking various types of scripts. So these are your call as well. You can go through and assess each one if you like and find out more information through some standard internet searching. But these allow you various types of script blocking, and in fact, there are even several others that include ad blocking and possibly even pop-ups. So it's entirely up to you, but if you find your browser experience is too often being interfered with by scripts and other types of pop-ups, then you do have the options to disable them and or to install a script blocker to make your experience more enjoyable and less disruptive. So in this course, we've examined basic concepts surrounding computer software and web browsers. We did this by exploring productivity, collaboration and business software, application delivery methods, application architectural models, and single and cross-platform software, software licensing, best practices for installing software, web browsers and browser caching, client-side and server-side scripting and disabling client-side scripting, using browser extensions, various browser settings, and blocking pop-ups and scripts. In our next course, we'll move on to explore basic concepts surrounding computer software development.